G'day team, welcome back to another video. So today we are continuing on with our vector work. So we've sort of started looking at some operations with vectors, so vector addition, vector subtraction, scalar multiplication, all right? Now we're going to look at the vector between 2 points. So more often or not, we have been looking at vectors from the reference point at the origin, all right? So over here. Now, this is often not the case when we start looking at problem solving with vectors. So we want to start being able to find the vector between 2 points. That may look like our diagram here. So we've got vector A, which is the position vector OA. So point A has the position vector, OA. Point B here has the vector position OB. All right, so that's just what I've written here, with components A1 and A2 and B1 and B2 respectively. All right, so now if we're wanting to find this AB here, remember we're having to add tip to tail. So if we want, this is our resultant vector, we start at our tail and we work our way around to the tip. So if we're starting at the tail, then we need to go down to O. So this is actually going to be the vector AO. Then we're going to add the vector OB, all right? So that's what I've written here. So AB is equal to AO plus OB. Now, hopefully you've noticed that AO is actually just OA, but in the reverse direction. So we can write that as negative OA plus vector OB. And rearranging that just so it's a bit nicer, so we have that operation in the middle there. Vector OB take away vector OA. We have our general components for those two vectors over here. So we're going to substitute that in. So we've got B1, B2, take away A1, A2. All right. Now that we've done our operations with vectors, we know exactly what kind of result we're going to get here. We're going to get the two horizontal elements. So B1, take away A1, and then the two vertical elements, B2, take A2. So the position vector of B relative to A is the vector AB, which equals OB minus vector OA, which equals B1 take A1 and B2 take A2. This will be our general formula. So these will often be given as points, okay? So as long as you remember this second letter is the first point, all right? And we're taking away the point at that first letter, all right? Let's do a quick example. So we've been given the points P, Q, and S, and they are respectively 3, 7, 4, -3, and -2, -4. So find the position vector of Q from P. So Q from P, part B, S from O, so O is the origin, and C, P from S. So let's have a look at A first, all right? So Q from P, all right, means we're going from P to Q, all right? So we've got vector PQ, and that is equal to point Q, all right? So point Q, take away point P. So 4 take 3 is 1, -3 take 7 is -10. And that's all it is. It's just remembering what order we are from, going from and to, all right? B, origin to point S, so vector OS. We look at the vector components of this second letter first, so -2, -4. Take away the origin, so taking away 0. So it has the position vector -2, -4. And finally, C, S to P, so that means we've got point P, take away point S, 3, 7, take away -2, -4, 3, take away -2 is 5, and 7, take away -4 is 11, all right? So hopefully that clears that up a little bit. Remember, the keys to this is having the point of the second letter minus the point of the first letter, all right? Have a crack at some questions, and we'll see you guys in the next video.